Number 3, this figure over here shows a slab with dimensions d1 equals to 11 centimeters, d2 equals to 2.8 centimeters, and d3 equals to 13 centimeters. Half the slab consists of aluminum, density 2.7, and half consists of iron, density 7.85. What are letter A, the x coordinate, letter B, the y coordinate, and letter C, the z coordinate of the slab's center of mass? Okay, so what is our strategy here? So let's say this is the origin of our coordinate system over here, and we are going to transform this continuous piece of metal into one point, a single point. So this slab, we're going to transform it to a single point over here, and this other slab over here is going to become another point. So at the end of this problem over here, all we have to do is to find the center of mass of those 2 points. And this point over here, this red point, it's exactly at the center of mass of this slab. And this point over here is exactly at the center of mass of this point. So we are going to find the center of mass of the iron slab and convert the iron slab into a point. And we are going to find the center of mass of the aluminum slab and convert the aluminum slab into a point as well. And then we have only 2 points, and then we can find the center of mass of the system. So since the composition of both slabs are uniform, the center of mass of this slab is exactly at its middle, and the center of mass of this slab is exactly at its middle as well. So for the iron slab, its center of mass in the x direction, it is in this position over here, right? This is d3 over 2. In the y direction, it is in this position over here, so it is d1 over 2. As for the z direction, it is in this position over here, which is d2 over 2 over 2. As for the aluminum slab, it's the center of mass of its x coordinate is at this point as well. So again, d3 over 2. Its y coordinate, now it's a little bit different because we have to sum d1 plus d1 over 2. So it is d1 plus d1 over 2. And its z component, it is the same as before, so d2 over 2. So those are the positions of the center of mass of the iron slab and the aluminum slab. So we only have 2 points, and we have to find the center of mass of the system composed of 2 points. So for letter A, the x position of the center of mass is equal to the sum of the masses times the sum of I equals to 1 until n of m1 times x1. So in this case, we have 1 over the mass of the iron slab, so let's say it is m1 plus m2 multiplied by m1 times d3 over 2 plus m2 times d3 over 2 as well. Okay, so we can put d3 over 2 in evidence. So this is going to be 1 over m1 plus m2 times m1 plus m2 which multiplies d3 over 2, and of course we can cross this out, so the answer is d3 over 2. So d3 is equal to 13, so this is going to be 6.5. So 30.2, this is going to be 6.5 centimeters. So assuming this is the origin of our coordinate system, right? Okay, so for letter B, we have to calculate the y coordinate of our center of mass, which is again the sum of the masses, times E equals to 1 until n of m1, mi, yi. So we have to replace here, so it's going to be m1 plus m2, which multiplies m1 times d1 over 2 plus, let's see, m2 times d1 plus d1 over 2, right? Okay, so in this case, we cannot do the same thing as we have done before, so we cannot cross out the masses. So we have to find their masses. So how we do that? Let's remember that the density is equal to mass over volume. And their masses, we don't know their masses, but we know their volume because we know the dimensions, d1, d2, and d3, and we know their density. So m equal the density times the volume. So this is equal to the density times d1 times d2 times d3, right? So this is their masses. So in this case, so let me go over here. So 1 over m1 plus m2 times, sorry, let me replace this by, well, you know the volume is d1 times d2 times d3. So it is the density of the first part. Let's say it is d1 times the volume. Their volume is the same, plus the density of aluminum times its volume, multiplied by the density of iron times its volume times d1 over 2, plus the density of aluminum times its volume multiplied by d1. So this is 3 over 2 d1, right? d1. And then you can cross out their volumes if you want, but you just, you know the value of every letter over here, so you just have to replace the letter by the numbers, and then you are going to find, let's see, oh, let's do another step here. You can cross out the volumes. So now you have 1 over the density of iron, which is 7.85, plus the density of aluminum multiplied by the density of iron times d1, which is 11 over 2, times 2.7, which multiplies 3 over 2 times 11. Okay, and this gives us 8.3 centimeters. So that's the answer of letter B. Just needed a little bit of calculations, but the physics is pretty simple. Letter C, the z coordinate. So for the z coordinate of the center of mass, this is equal 1 over the sum of the masses times I equals to 1 until n of m1 z my zy, and in this case this is the sum of the masses, m1 plus m2 times m1 times d2 over 2 plus m2 d2 over 2 as well. Okay, so again we can put d2 over 2 in evidence. This is going to be m1 plus m2 over m1 plus m2 times d2 over 2. So we can cross out the masses, and the answer is d2 over 2, which is 2.8 divided by 2, which is equal to 1.4 centimeters. So that's the answer of letter C, and that's it.